Hey, fourth grade, happy Monday. Here's your math lesson for today. We are talking about comparing decimals in different ways. So, you should have already warmed up on extra math. And I hope that you have out a pencil and a piece of paper and you're going to take notes and pause along with me. We'll just be kind of solving these problems together as we go. Feel free to pause whenever you need to. All right, let's get going. So, we are starting out with some comparisons here. Let me just choose a color. Okay, this one. The first problem we have, and you can pause here to write this down. I know that this is a little crazy, but if you want to write it down, you can. We're going to compare 1700ths to 2/10ths, or 0.17 to 0.2. The reason why these grids are down here is because that is one way you can compare decimals visually, just by looking at them. So, I know that in the hundredths place, these are all equal to 100th. If I'm going to color in 17 of them, I'm going to color in a whole row of 10, and then 7 individually. 1, 2, 3, 4, 5, 6, 7. So there's my 1700ths. I did it down at the bottom in blue. I'm going to fill in 2/10ths. I know each of these represents a tenth, so I'm going to put in 2 of them. 1, 2/10ths. Now, visually looking at these, I know that 1/10 is the same as 10/100ths. There are 2/10ths here, 2 complete rows. There's only 1 complete row here. So that tells me that 2/10ths is a larger number. Now, when you're asked to compare, you have to use those special symbols. And we always open the symbol to the bigger number, right? It's like that alligator mouth we've talked about so much. So we would say 1700ths is less than 2/10ths, right? Because this is the greater number, okay? I can see that 2/10ths fills in more of this whole than 1700ths does. Another way we could have done this is use place value. Okay, so I'm doing a different color here. I would start by looking at the ones place. Okay, well, in the ones place, there's both zeros, so that's not really useful for comparison. Let's go to the tenths place next. This one has a 1. This has a 2. Oh, 2 is greater than 1, so 1700ths must be less than 2/10. So you're using the tenths place here to compare. You don't even have to worry about this 7 in the hundredths place. Okay, so there's one example. Our next example is comparing using a number line. So here we have 11 and 5/10ths and 11 and 7/10ths. So if I were to draw this on my number line, I'm going to go from 11 to 12. Okay, start with 11 on the left side. Then we have 12, right? Because 11.5 and 11.7 are between 11 and 12. Now I need to put in, because I have tenths here, my tenths in between. The first one I'm going to do is smack dab in the middle, just because I feel like that's easier for me visually. So that is 11 and 5/10ths, or 11 and a half. And look, we've already established where 11.5 is on that number line. Now I'm going to do my tenths in between. Okay, so I have 11, 11 and 1/10, 2/10, 3/10, 4/10, 5/10, 11 and 6/10, 7/10, 8/10, 9/10, and then 11 and 10/10 is actually the same thing as 12. So now let's find on this number line, where is our 11 and 7/10? Well, if this is 11.5, this is going to be 0.6. There's 11.7, or 11 and 7/10. Let me put a little dot on our number line here so you can see 11.5, 11.7, or 11 and 7/10, 11 and 5/10. Which one is greater? Which one is further over on the number line? 11 and 7/10. So my alligator mouth goes towards, again, it is less. 11 and 5/10 is less than 11 and 7/10. Again, if you're doing this visually and you don't have a number line, we see that in the tens place, same number, ones place, same number. Tenths place is where it's different, and that's what we use to compare. Okay. All right, I'm moving on to another board. We're still comparing numbers. So we've done it with grid, just looking at it visually. We've used place value. We've used number lines. Those are all some options. This next one, okay, is, comparing decimals that are in different forms. So it's not even just going to be decimals, they're going to be fractions too. Let me show you what I mean. Okay. Oops, I just realized that I made a mistake here. Let me fix it really quick. Okay. So we're going to compare a decimal and a fraction. We have 2 7/10 and 2 17 hundredths. So we have a couple of options here. The first option we have is to rewrite 2 7/10, the decimal, as a fraction. We know how to do that. It's going to be a mixed number. So our whole is 2, and then we get 7/10. Okay, so I can look at these and compare them and think to myself, reasoning about the size of tenths and hundredths. And if it doesn't totally scream out at you yet, think about it like this too. We can just add our zeros here to make this into hundredths, so it's easier to look at. So 7/10 then becomes 70 hundredths. 70 hundredths. So looking at it this way, I can tell you that this 2 7/10 is greater than 2 17 hundredths. Remember, the mouth goes towards the greater number, the bigger number. Okay. Another option we had was to actually rewrite our mixed number here as a decimal. So 2 17 hundredths is the same thing as 2.17. Okay, I've rewritten this one as a decimal. So we know that there's like that invisible 0 there, right? You could also use place value to compare. One's place is both a 2, but in the tenths place, there's a 7 here, but a 1 here. So again, we can prove that 2 7/10 is greater than 2 17 hundredths, okay? My recommendation for you would be to use the form of the numbers that works best for your brain. So if you like turning them into fractions and that makes more sense, do that. If you like turning it into a decimal because that makes more sense, do that. All right, now I'm going to give you a problem where you're going to decide based on these different forms of numbers which are less than a given number. So here's our problem, and you can write this down if you need to. Which of these 3 options are less than 2 3 hundredths? Okay, pause if you want to write this down. Right here, by the way, it's separated into tenths, and there are 2 filled in. Okay, my strategy here, because the number they gave us is a decimal, we're going to write all of our options as decimals so then we can look at them visually and compare. So our first one with the grids. Well, I see that there are 2 whole boxes filled up, so that tells me that I have 1, 2, and then like I told you, 2 out of these 10 are filled in, so that's 2 tenths. So I have 2 tenths written as a decimal. Next one, this says as a mixed number, a fraction is 2 12 hundredths. How would I write that as a decimal? 2.12. 2 12 hundredths. The next one says 23 hundredths. Now, how am I going to write that as a decimal? Let's think about it for a second. You may be tempted to put like a 2 in the ones place here, but there is not a whole number in this example. 23 hundredths, my friends, looks like this. 0.23. Look, there's not a whole number here. So with that in mind, okay, looking at 2 3 hundredths, which one of these numbers is less than that? If you said 23 hundredths, you would be correct. That's the only one that's less, okay? Don't let it confuse you that there's still a 3 here because there's a 2 in the tenths place. Or actually, that doesn't even make sense. Don't let any of that confuse you. Forget what I just said. This is the only one that's less. Okay, I'm going to show you another way we could have compared these numbers, and I'm going to write them in pink. Okay, so we could have actually turned this number here, 2 3/100, into a fraction, which is 2 3/100. Okay. Have that there in pink, 2 3/100. This number, 2 2/10, as a fraction, okay, is kind of like that. That one's easy. And then 2 12/100. Okay. I also know that 2 2/10 is the same as 2 20/100. So that's easier to compare. And then finally here, it's actually just 23 over 100. So again, even as fractions, all of the pink, you can tell that this is the only one that is less than 2 3/100. Okay. We've got one more problem to do together. We're going to order these numbers from the least number to the greatest number. So let me show you. Order from least to greatest. You can pause here to write these down. Let me fix this. It's actually 2 59/100, 2.59. So hold on just a second. Sorry, guys. 2.59, 24/10, and then 2 3/10. So I think just because that first number in the list is a decimal, I'm going to put them all, the rest of them, as decimals. So that means we only have to change 2 of those numbers. Let's do this in blue. Okay, so 2 59/100 already a decimal. 24/10 as a decimal. Well, I know that 24/10 is the same thing as 2/10. Okay. And, oh no, I'm lying to you. Let's break it down. It's 20/10 and 4/10. So that's as a fraction, but 20/10 we know is the same thing as 2 wholes. So that's going to become a 2, and then I have 4/10 left over. As a decimal, I get 2 4/10, 2.4. That's because those 20/10 are 2 wholes. That's where we got that whole number 2. Okay. Last one is 2 3/10. I can write that pretty easy as 2.3. Okay, so down below here now, looking at my answers, I am going to order them from least to greatest, so the smallest number to the greatest number. You should have 2 3/10, 2 4/10 as your second one in the middle, and then finally 2 59/100. Okay. So another way to look at this would be just to use the place value to order them, right? If it didn't automatically jump out at you. I'm looking at my tenths place here, okay, and I can underline that for you as well. In the tenths place, you can see that they go in order 3, 4, 5. So even though this is in the hundredths place, 2 59/100 is more than 2 4/10 and 2 3/10, because remember we have those invisible zeros there too. So it's kind of like 2 30/100, 2 40/100, and then 2 59/100. Still the greatest one out of all of them. Okay. All right, my friends. All of the examples we just did together are going to be very similar to the 3 Khan assignments you have. So come back and use them if you need to. I hope you enjoyed today's lesson. We will see you tomorrow.